first thing that we're going to commonly be doing when we service these ACs is a performance test. So we got to do one last week. There's a lot of different preferences on exactly how you're going to do this, but overall, we're going to turn on the vehicle. They say to put a fan in front of the vehicle to simulate airflow when driving, but I actually would not do that, and I'll explain why. Close the windows, turn the AC on max. So max meaning full blower speed, recirculate, or some like on Fords it'll say max AC, whatever gets you the most cool, high performing AC. And then I also don't do this step. Raise the RPM to 1200 or 2000, and then leave a thermometer in the center vent, see how low it goes. All right. The reason that I don't do the fan in front of it is because this will cover for a defective cooling fan. So I wouldn't do that step. And the reason why I don't raise the engine RPM is because on a modern vehicle, you should be able to make max AC just at idle. On an older car, maybe not max AC. So I'm okay with doing max, or on an older car, you might not make as cold AC as possible at idle, but on the newer stuff, especially with a variable displacement compressor, we can definitely get the coldest we can get without raising idle. Okay, so I slightly modify those. The reason I like to cover it like this is how it's called out right in the book. Okay, and once in a while, the manufacturer will specify how to do a performance test, but most of the time they don't. All right, so let's just say we're gonna get a bit of a perspective here on what you may run into. Okay, so we'll start a little bit with the symptoms and the pressures. We'll get into the service, and then we'll cover the components. So I want your brain now to be focused on what failures would cause what symptoms. Okay, if we have an undercharged air conditioning system, that means it's contains less refrigerant than spec. So if it calls for 2 pounds and it only has 1 pound, that could be because a leak or it was improperly charged. It's probably going to be the leak, right? But sometimes it is undercharged. If it's undercharged, here's the symptoms for an orifice tube. Okay, that's a fixed orifice. That's not a thermal expansion valve. On a fixed orifice tube, it's going to cause a rapid turning on and off of the AC clutch. AC will call this short cycling. It'll turn on, it'll run, it'll turn off. On, off. On, off. Click, click. If you've ever heard that on a orifice tube style, there's a good chance that's undercharged. The reason why, it'll try to run it, it'll wait for the pressure to spike up when the compressor's on, and if it doesn't spike up in a certain amount of time, it'll kill it, right? It'll activate the compressor clutch, run, and then the pressure switch will say like, yeah, I never hit whatever, 125 or whatever the switch is set for. If the switch doesn't build pressure, that means basically it's got to be low on refrigerant. It's a self-protection procedure, because if you've lost refrigerant, you've probably lost your oil. If you've lost your oil, what happens if you keep running the clutch and running the compressor? What do you think is going to happen?
You burn it out.
You'll kill that compressor. Yeah, exactly. So on this system, if the charge is low, it won't make enough pressure. It will shut off prematurely and just keep cycling, rapid cycling. Again, ASE would call that short cycling. And the other thing is, on an orifice tube system, the ASE will call that a CCOT, cycling clutch orifice tube. Okay, log that in your brain. What if it's a TXV though? A TXV system is much more sensitive to low charge. So the cycling clutch orifice tube, actually, like, they could be kind of low and they'll still work until they're really low. But a TXV, if it's a little bit low, it's probably going to stop working pretty quickly. All right. If the air conditioning system is running below atmospheric pressure, any leak on the low side will allow air and moisture into the system. Interesting, because it makes a nice low right there. If air and moisture contaminate the air conditioning system, acid will be created in the oil, which will corrode the aluminum on the components, right? When it's low, the air duct will feel slightly cool, and the AC gauges on both the high and the low sides will read below normal. So if you have the low side too low and the high side too low, that's a low charge. That's also true on the cycling clutch orifice tube, but it's more apparent on the TXV. You can see it easier. All right. However, so understand that because we're going to see one of those gauge sets, and you'll probably see something like that in the ASE. What about if you overcharge it? Overcharging will affect the orifice tube and the TXV exactly the same way. Both the low and the high side gauges will be running higher than normal. Right. So if you have gauges low and low, that's undercharged. If you have gauges high and high, that's overcharged, right? So if both low and high are too low, undercharged. If both low and high are overcharged are too high, that's overcharged. Okay. You must know these. But we're also going to cover it one more time under diagnosis. I'm just getting your brains ready for how how knowing all these components and their operation is going to help you diagnose. Okay. The air ducts will feel slightly cool. The AC compressor clutch will run for a few seconds, then turn off for a long period, a long time, and then it'll run, and then it'll turn off and stay off, right? See the difference? It's staying off because if it's too high, the high side cutoff, it'll actually trip a switch and say, whoa, we're making way too much pressure, shut it off to protect itself from grenading, from blowing itself up, and it'll time out for longer. Okay. And then just a general performance test, this is one of the only ones I found documented, right? If it's 55 to 65 degrees, you should have about 25 to 30 on the low, 49 to 123 on the high, and you should get about 45 on the vent. Okay. And you can reference this chart for a number of things. What I'd like to point out is once you get up into like 86 to 95, it really starts to change based on humidity. So if you're 86 degrees with 30% or less humidity, 28 to 43, 146 to 205, you should get about 54. But if your humidity is over 50%, you're going to get maybe 58. And it's probably actually going to be a little bit worse if it's closer to 100% humidity. So it's interesting that the humidity will affect your discharge temperature. Remember I was saying that when somebody says, oh, what temperature should the vent blow at? Well, anywhere between 45 and 66, depending on ambient temperature, depending on humidity, right? So it's all over the place. So again, it's much cleaner to do the compare to a known good, it's much cleaner to compare it to what you're seeing that day at that time with another known good. Make sense? Because these are kind of variables. Now, notice something. If it's 106 to 115 and over 20% humidity, 43 to 55, 235 to 280. 280 to me looks too high. Why do you think that high side is so high? 280 is high. Like I'm usually looking for like low twos, mid twos. You know why it's high? Because remember, temperature and pressure have that relationship. So if your temperature's high, your pressure is going to be high. If your temperature's high, your pressure is going to be high. Now, if you look at the high side, if it's cold out, if it's 55 degrees, it's actually going to be pretty hard to test that AC. So if it's 55 degrees, your AC should be blowing at 45. Like even if your AC is totally inop and you're blowing at ambient, you're probably going to be blowing 55, So it's really hard to test AC when it's cold, but you can see there's a huge difference in your high side from 55 to 115. 49 to 280. That's huge difference. So how much pressure really depends on temperature. But I'm going to be honest, on the ASE, they're not going to be asking you to diagnose high side pressure at 55 degrees outside. That you're not running AC at 55. If you are, there's something wrong. Seek help. Seek help. Get help. More likely it's going to be 80 something. So look, if we're 85 or 86 or 95, you're 171, 146 to 205. You're getting closer to that 200 number, right? So we're running mid 150s, upper hundreds, 200s, those are normal numbers commonly. Okay. So as we get a little bit further in, here's normal. 32, 35 PSI low, 220, 225 right there on the high. That would be a normal reading. Now, technically, that's probably going to be at 90 something, 100 degrees. You know, so if you see a reading like this on the ASE, that's normal. Like it, love it. What about low, low? You've got 25 on the low and about 160, 170 on the high. 25 on the low. It's almost possibly normal at 76 to 85. But again, most of the time they're asking these questions, it's going to be warmer because when the car comes in for AC not working well, it's probably pretty hot out. All right. I like that you guys are guessing in the chat. If a compressor isn't compressing, the low side won't be low enough. The high side won't be high enough. The compressor builds the high high and draws the low low. Okay. But both of these are low. So right here, if you look at this, low on the low and low on the high, that's just undercharged. That's it. Undercharged. Perform a leak test. Find where the leak is at. Ooh, look at this. This is high. All right. 55 on the low. 425 on the high. Yikes. 55 on the low, 425 on the high. Yeah, I don't see no 425 on this list. Again, the low is high and the high is high. I previewed this for you. The low is high and the high is high. They're both high. If both of them are high, it's overcharged. This is an overcharged. The other thing it could be, it could have a defect in the system where it's unable to get rid of heat. If you guys think about it, there's a component in the system, an AC specific component that gets rid of heat. Anybody remember what it is?
A condenser.
Exactly. Now, how does the condenser get rid of heat? What takes the heat away? Let me ask it that way.
The state change from gas to liquid.
True. So that's how it gets rid of the heat, like in the refrigerant cycle, yes. But once the heat's in the condenser, what gets the heat away from the metal of the condenser? Ah, there we go.
Condensation.
It's in the chat. The cooling fan and the airflow. All right. So I pick up all those answers were good. Yes. We condense the refrigerant and that dumps the heat off into the metal, but then we need airflow to carry the heat away. If you don't have correct airflow, the heat will be dumped out in the condenser, but the airflow won't carry the heat away. So this high is probably overcharged, but if we had an airflow issue, that could cause it too. All right. So keep these things in mind. That's when I'd be looking at that fan. I'd be looking at that fan. I'd be looking at the condenser fins, etc. All right. So like, for example, shining the light right here, seeing if we have a lot of blocked condenser fins, seeing a lot of bugs and bees and dirt and all kinds of baloney in there. That could make the high a little high and the low a little high too. All right. So that's just a good tip for you. And then let's just say if they're both high, you could actually use shop air or water hose to clean the debris out. Makes sense. I would even go back to that fan that we saw very early on the performance check. And, you know, if it runs hot without that fan, but I put that fan in front of there and it cools down, I'm thinking like, yeah, this is a cooling fan issue for sure. Right. What about if we have the low side pressure low, or sometimes even negative pressure, which would mean vacuum, and the high side pressure is high. So the low is too low and the high is too high. You'd be like, well, wait. Remember the kink in the hose, right? If you got pressure coming in and there's a kink in the hose, but it's a little bit open, the high pressure will bleed off a little bit, come down, and the low pressure will come up a little bit because there's more water flow through the kink. Well, if we had a completely like an overly restricted orifice tube or a stuck closed TXV, or sometimes you know what happens? Moisture in the system hits the TXV needle and freezes right there, turns into ice, and then it becomes a high high and a low low. too much of a difference between the two is probably not because your compressor just got a shot of nitrous oxide. It's although a compressor would cause that if it was overworking. Compressors, they're not really overachievers. What it is the kink in the hose is totally closed off. You got a complete restriction in your restriction device, more of a restriction than you should. That orifice tube is clogged up. That TXV is stuck closed. So this is a TXV type of concern. There you go. This one's for something. This one is right near zero. Sometimes they'll even literally suck it into negative. And that was true, but one thing I would like to actually point out on that, which we covered in diagnosis, is yes, the high that's too high and the low that's too low will happen. But remember, the high side relies on being able to suck the refrigerant from the low side, right? And if there's a restriction, eventually this high side will actually start to starve for refrigerant, and they'll both end up kind of low, but this one will be a lot of times in the negative. The compressor will be trying so hard to pull refrigerant into it, it'll actually suck the low side down to negative. That would be after like a few 20 seconds or so, but for a little while it would look just like that. All right, kind of fun. Low side pressure is high and the high side is low. So look at this. It's not real crazy, but this is 70 PSI and this one's about 70, 80 PSI. What draws the low low and what makes the high high? The compressor does that. That's its job. The compressor along with the restriction device. So if you had the restriction device completely removed and the refrigerant could free flow, that would cause that too. But that's not really a thing. This is the thing. The compressor is lazy. The compressor is weak. It's not able to suck the low side that low, and it's not able to build the high side that high. See, these are about the same, right? They're both about 75, roughly. If you were looking at bar, it's just over 5, and this one's at 5, so they're about the same. That compressor is doing jack diddly. Cool. Again, when we are doing this type of service work, we talk quite a bit about leak tests. I have my own preferred methods, but I'll expose you to all of them. We will talk about this electronic leak detector too. Yeah, the compressor's fired. So when we get in these electronic sniffer types, they have ultrasonic. That's a type of leak detector. There's heated diode, corona suppression. They're just different technologies. The way we use them is kind of the same. You hold it up there and it'll beep, 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 right? That's something that we're going to do this week. They require that the AC system have a charge of refrigerant and the leak, they have to be charged for the leak detector to find the leak. So if it's already empty, any sort of leak detector is not going to work out. Makes sense? So you'd have to charge it and then check for leaks, which is part of the reason I like the dye. Cool. All right, so like this one, for example, this is powered up and this wand bends around right here and is going right to that hose. And if it's ultrasonic, it'll actually hear it can actually hear it. Some of the other like corona suppression, these ones, sometimes they detect it chemically. Makes sense. So they're different versions. Okay, and then after we fix it, of course, recheck it for leaks. Like there you can see the sniffer right there, checking for leaks. They do tend to leak at right here at the line, actually. That's one of the things we cover a little bit later. All right, but for me personally, I like the dye. I already showed you why, like I would rather just put the dye right in the oil. That way every service I do, the car gets dye. However, this is going to show you a little bit different. Some machines have the port. Some other ones will use like a syringe. So I'm going to actually show you that. Here's one that we were able to find the dye. This one, to be honest with you, I saw that picture and I was like, oh, that's a good one. Wait a minute. Probably what happened is there was dye in the oil of the machine. And when you pop the fitting off, if there was a little bit of pressure built up, it will leave this. I don't actually think that's a leak. I think that's from putting oil in. If it is a leak, it'd be that Schrader valve, right? We already saw one that was no good. That's pretty typical. But if that green was over here where the crimped fitting, where it goes from rubber to aluminum, now we found a leak. I got a couple good videos and you're going to notice we're going to go through the process of performing the AC service. it's supplemental to the videos. The videos are pretty thorough. We got a really good one, finding an AC leak using UV, was a really good one. The other thing that we could use is inert gas testing. It's inert so that when the AC compressor fires up and the compressor clutch and stuff, it's not flammable. But also, we could inject it with shop air pressure, just like how we put air in tires and then we spray them and look for bubbles. But the shop air has moisture in it, and that's really hard on the desiccant. So it's actually better to use nitrogen, for example. We got nitrogen hooked up. We're pressurizing it with nitrogen. And once it's pressurized with nitrogen, we can spray soapy water, Windex, whatever, and look for bubbles, just like checking a tire for leaks, you know. So these are the typical procedures. And then another form of diagnosis is straight up electrical, right? So when we look at all this, yeah, ACIC, wait a minute. This is literally just electrical. So as we get a little further into this, we'll look at some diagrams, but we may simply have a compressor clutch that won't engage the compressor, won't run the compressor. It'll give us the symptoms of a defective compressor, but the compressor is not going to compress if the clutch doesn't engage, assuming it has one. We'll get into the different types of compressors later, but sometimes AC diagnosis is just very simply electrical diagnosis. It might be a relay, it might be a fuse, it might be a wire, it might be, you know, this clutch coil, it might be a ground, it might be, you know what I'm saying? It could be totally electrical diagnosis through and through. All right, so be ready for all those types of things. Here's the compressor clutch, for example. This compressor clutch needs 12 volts in ground to magnetize, click, and then rum, bum, 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 right? You guys saw that last week. If it's not getting 12 volts in ground, well, that could be because there's a problem in the circuit. Could be. But, and this is a big but, not necessarily. If your refrigerant is low, your low pressure sensor or your pressure switch will read low because it's undercharged, and it will prevent the compressor from running because he knows if it's low on refrigerant, the refrigerant carries the oil. It's probably low on oil and there's no good way to move the oil, so it might lock the compressor out. So you might be over here like diagnosing this relay and all this type of stuff. It'd be a good idea to just get your pressure readings. If your pressure readings are really low, like 0, that's probably why the compressor clutch relay is not clicking, because the control side is preventing it, okay, as an overall, right? So be ready for that. Now, we'll get into the service, and you guys have done the 609, and you guys have, if you haven't, you can watch the video step by step how to use both types of machines, right? But overall, I want to just give you an explanation as to what's going on when we do those machines. When we're going to remove the refrigerant from the system, it's called recovering. So you guys are about to come in and do a bunch of condensers and compressors and stuff. Let's recover the refrigerant that's in there. Fair? Let's recover whatever's in there. And that's what recovery is. We're going to literally recover it. That could be done with a standalone machine. This is recovery only, and you'd have to have one for each type of refrigerant, but we're not probably going to do that. We're going to use the RRR machine, recovery, recycling, recharging type of machine. That's all the AC machines that the dealer's going to use. Right. But before we do, we should really identify it, make sure it's got the right refrigerant and et cetera. And then the other thing we need to do, you can drain this oil so that way you can see how much came out, or you can look at the numbers and see how much is in there. Because remember, when we recover, it's going to pull some oil with it. And however much it goes up is how much we need to put back in if there's no leak. If there is a leak, we might have to put a little bit more oil back in, but not the capacity of the sticker. Absolutely not. All right, so check the oil, the used oil container, or empty it, right? Find the low and the high, hook them up. You can see on this one, it says recover. You got recover, vacuum, inject oil, charge. That's kind of nice because that's the order we do them in. Okay, and then it's going to say when the process is completed, you need to know how much came out, right? That's going to tell you a lot. So if you had symptoms of undercharged and it called for 2 pounds, and you recovered 2 pounds, it wasn't undercharged. If you have symptoms of undercharge and it calls for 2 pounds and you recover 0.7 pounds, you found the issue. It was undercharged. Make sense? So you have to note that. If you don't, you don't know. And if you're doing work, I may say, how much came out of that? If you say, I don't know, you're messing up, right? That's important. And then again, note the total amount of refrigerant that came out when we recovered. And then the next term is called recycling. Recycling is a term they commonly use, and this is kind of what it means. They're going to take the refrigerant and it's going to automatically recycle it. It's going to run it through the dryers. It's going to separate the oil. It's going to get rid of contaminants. And then it's going to take that refrigerant that you just recovered and it's going to recycle it into its own internal tank. So some of you noticed last week there wasn't tanks on every AC machine. No problem. That's normal. We don't need a tank on the machine. We just need there to be refrigerant in the internal tank. If there's not enough refrigerant in the internal tank, that's when we hook the external tank up and we move it into the internal tank. Make sense? It never charges from the external tank directly. Okay, just so everybody is very clear. Cool. So that's recovering, and then that's recycling. Recycling is filtering and conditioning it. And then there's evacuation. So evacuation is not in the RRR machine. It's not in the 3 Rs, but it's basically vacuuming. So remember, we talked a bit about vacuuming. It's to remove all the moisture. Evacuating requires either air conditioning gauges and a vacuum pump, or like what we're going to use, the RRR. But I will show you the vacuum pump style. Okay, we need to remove it. We need to pull it to a low enough pressure to effectively boil the water into a vapor or gas so that we can pull it out. We have to. We need to lower the pressure, and that's why we use the vacuum pump. You can even use the vacuum pump and look at your gauge, and you can see how much vacuum you're pulling. Cool. Additionally, it's a nice one because we can do a little leak test. If you run the vacuum pump and you get down to, let's say, 30 inches of mercury, and then you shut the vacuum pump off, it should hold 30 inches of mercury, like 10 minutes, 3 minutes, however long you want to test it. It should, the longer it holds it, the more likely it is that there's no leak, right? If it doesn't hold it and the vacuum degrades, it was 30 inches of mercury, that was 28, 26, 24, 22, 18, 12, and you're like, man, it's only been 3 minutes, and it dropped from 30 inches of mercury to 12. That means it's losing vacuum because air is leaking in. That's a leak. Makes sense? It's a pretty nice way to do it. Again, you need to watch the pressure. You need to time it. Typically, the time to achieve boiling point pressure at the ambient temperature with a 5 CFM vacuum pump is 5 minutes. So if you can't pull it down to the pressure you want, the vacuum that you want in 5 minutes or less, probably it's because it has a leak. Then again, it could be a worn vacuum pump too. So if it can't pull any car low enough, it could just be the vacuum pump. But if it can pull some cars low enough, but not your car, it's because it's got a leak. Just be aware. That's what you got. All right. And that's for a pretty strong vacuum pump. Now, I want to show you some pressures. So if we were to look at inches of mercury, we're typically trying to get closer to like 30. But what's interesting, if you notice, it goes 0, 4, 9, 15, 20, 24, and then it hits 29, 29, 29. It barely moves in inches of mercury. Inches of mercury is kind of vague and inaccurate, especially when you have a lot of vacuum. The cleanest way to really measure it is with a micron gauge. A micron gauge measures vacuum really accurately. Like a vacuum gauge is actually pretty good up to about 26, 27. And then once you're at 28, 29, like there's almost no difference between 29.02 and 29.92. But in microns, there's a huge difference. You were at 22,860 microns down to like 2.54 or 0 microns. The micron gauge is nice. In automotive, though, I don't really see techs using the micron gauge. Some of my friends are HVAC guys. They use the micron gauge. I've used the micron gauge with them a couple times. We pulled a vacuum on this AC unit right here, my shop AC unit. and he measured down to a certain amount of microns and timed it, how long it was going to take at a certain number of microns to get the moisture out. It was a little more sophisticated. To be honest, typically what we do, because we don't have the micron gauge, we'll just let that AC machine run vacuum for 30 minutes, 45 minutes, an hour. And that vacuum pump is going to just keep running and running and running. It's kind of hard on the vacuum pump, I admit. But if by the end of that 45 minutes, it better have got all the moisture out of it, and we didn't even reference it with a vacuum gauge, right? So we do stuff a little weird. If you meet somebody who has a micron gauge, I'm impressed. I want you to know about it. I don't expect you to get one. Not that it wouldn't be a good idea. It's just nobody has them. Right, so here we're doing it in a different way using a vacuum gauge. We're hooking up the high and the low, opening them up. We're literally running vacuum on this. You can see where the gauge is. The gauge is down in mercury right here. The gauge is down somewhere near 29, 28 inches of mercury. It's pretty good. We could time it. And the micron gauge looks like this. So you can actually hook this up and watch the micron gauge, which is again much more accurate than just the vacuum gauge. But this is not using an RRR machine. This is standalone. This is a standalone vacuum pump. You can use the vacuum pump, connect it to the yellow hose. The vacuum pump will suck down the yellow hose. And then what we would normally do is open up the low side line. And if you open up this blue knob right here, that valve, it'll connect the yellow to the blue. And if the yellow is getting all the suction from the vacuum pump and you pass it over to the blue, that means it'll pull the whole system down because the system is sealed, right? So that's how we'd pull the whole system down with a vacuum pump and a set of manifold gauges. Otherwise, normally we're going to be using this piece of crap, right? I mean, the RR machines are nice. I'm just saying. They're good to make you dummies, though. Right, so we could do it like that, run it 15 minutes, 20 minutes, an hour, whatever. You can see it's pulled down to probably 28 inches of mercury. That's good. We just don't know exactly how low it got. Microns would be much more accurate. Ooh, 730 microns. As long as we get it below 1,000 microns, we're happy. Now take a look at this. Went back up. If we get it below 1,000 microns, that's anything under this. So that's anything under 2987. It's under. Is it 2991, 299150, 29919? You will never be able to read the difference on your gauge to determine if it's under 1,000. And that's why the micron gauge is superior. Makes sense? But if somebody has one, let me know. Right. So there you can see it. Boom. And then when we're going to do the services, the thing you must know, after we pull it down to a specified vacuum to get rid of the moisture, that's when we're going to put some oil and dye in there. So in this case, we've got a special type of dye. We're putting this in the oil injector, or a special type of oil in the oil injector, filling it up. This one has dye in it too, so that's kind of nice. You're going to start this syringe. So this syringe is pretty typical. We have one at the school. Goes to the low side adapter. Literally push some of the oil out, push the air out so a little bit of the oil comes out, then hook it up and pump it. And that's how you shoot the oil in. Now, one of the more common ways is you literally press inject oil and you hold it and it'll suck the oil in. That's another way. But there's two different ways. Now, this way right here, you'd say like, this is stupid. This is old school. But this is the thing. On the R1234YF machine, that's got to be good for electric driven compressors and belt driven compressors. Electric driven hybrid compressor is going to take a different oil. So if you were to have the RRR machine, you need one for hybrid and one for not hybrid. So therefore, on a lot of the new R1234YF machines, they don't inject oil. They'll recover the oil, they'll put it in the drain, but there's no way for it to inject oil because they don't know which oil it needs. Is it a hybrid or is it a regular gas belt-driven one? Right, so you have to go get this and you have to inject the right oil separately. There's PAG oil for R1234YF and there's different PAG oil for R134. And then there's different specific oil for hybrids, right? So now we need standalone. This is a good tool for that. Cool. And then again, if you're about to charge it with this machine, you just type the number and you press OK and it charges it. It's dummy proof and I like it. It's good. But if you want to do it like this, you put your tank on a digital scale, tare, T-A-R-E, and that'll show 0. And then when refrigerant leaves it, because you're going to open up this low side fitting, it's going to actually pull the refrigerant in and the tank is going to get lighter. How much lighter? Depends on what the spec is. So if the spec is 1.5 pounds, let it suck it in the low side until the tank is 1.5 pounds lighter and then close it. And that's how you actually charge it by the book. This scale is literally going to measure it and show you a number. Right? And that's pretty much what it's going to do. Now there's a reason why I show these manifold gauges right here, because oops, they are right there. Because I want you to think about something. If you're trying to recover this, the high side is where the compressor's pushing. If you're trying to recover it, you'd open up the red valve, and that would connect the high side into the manifold gauge to the yellow, which goes to the tank. And if the high side is connected, it's going to push the refrigerant into the tank. The high side pushes, assuming it's not temporary. If it's temporary, there's a check valve. You can't recover with a temporary. But if it's a permanent actual refrigerant tank, it'll take the refrigerant right in that tank. Then when you're ready to charge it, make sure the red side's closed, open the blue side, because remember the blue side is drawing, it's suction, it's low. If the blue side is suction and you open up the blue valve, it's going to connect the low side to the yellow hose, and that's going to suck it out from the tank into the low side, and you're just going to measure how much the tank weighs, and then you know how much you charged. Cool. It's not exactly rocket science. And then let's just say we have an issue, like maybe the compressor blew up, and we need to flush it. This is what an actual flushing system looks like, right? So this is a specific type of a flusher. A lot of times they'll use alcohol, not water. If you use anything water-based, that's going to add way too much moisture. Your desiccant's all going to be full. It's going to mess it up. Alcohol is dry. It goes through and it evaporates really fast if you leave it open. Cool. So there's your flush machine. All right. That's an overall of the service. Again, it's going to be coupled with the how-to, the step-by-step. I show you how to do it with a machine, without a machine, every step of the way with the